Hello friends, welcome back to EduSeeker YouTube channel. In here we are going to look at foundation concepts of chemistry. There are three parts of this section. So in this video reveals the second step for foundation concepts of chemistry. First of all, want to say that if you are new to our channel, subscribe our channel and also click the bell icon to get notifications of our latest videos. So let's begin. Energy is the second category of the foundation course of chemistry. Much of chemistry is concerned with transfers and transformations of energy. We begin here by reviewing classical mechanics, which describe the motion and energy of particles. These classical ideas prepare us for quantum mechanics. Molecules are built from atoms and atoms are built from subatomic particles. To understand their structures, we need to know how these bodies move under the influence of the forces they experience. The velocity of a particle is the rate of change of its position. The velocity and position are vectors. What is vector? It means a quantity having direction as well as magnitude. The magnitude of the velocity is the speed. Linear momentum proportional to velocity. If a velocity of matter increases, its linear momentum also increases. The linear momentum p of a particle of mass m is related to its velocity v by p equal mv. According to the Newton's second law of motion, the rate of change of momentum is equal to the force acting on the particle. Delta p divided by delta t equal f. P stands for linear momentum. Also, it equal to the multiplication of mass and velocity. The rate of change in velocity called acceleration. When we add this to Newton's formula, we get F equal ma. The rotational motion of a particle about a central point is described by its angular momentum. The angular momentum is a vector. Its magnitude gives the rate at which a particle circulates and its direction indicates the axis of rotation. The magnitude of angular momentum J is equal I omega, where omega is the angular velocity of the body rate of change of angular position and I is the moment of inertia. What is that? Inertia means a tendency to do nothing or to remain unchanged. Moment of inertia is a measure of its resistance to rotational acceleration. For a point particle of mass m moving in a circle of radius, the moment of inertia about the axis of rotation is I equal mr squared. To accelerate a rotation, it is necessary to apply a torque. Torque means a force that tends to causes rotation. Analogies between rotational and translational motions. Displacement of rotational motion represented as theta. In translational motion, it is represented as s. Velocity of rotational motion represented as omega. In translational motion, it is represented as v. Acceleration of rotational motion represented as alpha. The translational motion is represented as a. Cause of acceleration is of rotational motion represented as torque. In translational motion is represented as force. Inertia of rotational motion represented as moment of inertia I equals sigma mr squared. In translational motion it's represented as mass. Newton's second law represented in rotational motion as tau equal I alpha. In translational motion it's represented as F equal ma. Work in rotational motion represented as tau theta. In translational motion is represented as Fs. Kinetic energy in rotational motion is represented as half I omega squared. Translational motion is represented as half mv squared. Momentum of translational motion represented as P equal mv. In rotational motion, it's represented as L equal I omega. Before defining the term energy, we gotta describe briefly about the term work. Work is done in order to achieve the motion against an opposing force, W equal Fs. This is an equation of a scalar product, work, which is the multiplication of vectors, forces and displacement. W equal Fs, equation used for motion in one dimension. The unit of work are joules. Energy is the capacity to do work. It's also measured by unit joule. The rate of supply of energy is called the power, and it's expressed in watts. A particle may possess two kinds of energy, kinetic energy and potential energy. The kinetic energy of a body is the energy the body possesses as a result of its motion. For a body of mass m traveling at a speed v, E equal half mv squared. A potential energy EP of a body is the energy of it possesses as a result of its position, because the work that a particle can do when it is stationary in a given location is equal to the work that had to be done to bring it there. No universal expression for the potential energy can be given because it depends on the type of force and the body experiences. For a particle of mass m at an altitude h close to the surface of the earth, the gravitational potential energy is EP equal mgh plus 0, where g is the acceleration of free fall. G depends on location, but its standard value is close to 9.81 m to the power s2 minus. The zero of potential energy is arbitrary. For a particle close to the surface of the earth, it is common to set the total energy of a particle is the sum of its kinetic and potential energies. We make use of the apparently universal law of energy that energy is conserved, that is, energy can neither be created nor destroyed. Although energy can be transferred from one location to another and transformed from one form to another, the total energy is constant. The terms of the linear momentum, the total energy of a particle is E equal p squared over 2m plus v. Coulomb potential energy. Coulomb potential energy is one of the special kind of potential energy. This happens between two electric charges. The Coulomb potential energy is equal to the work that must be done to bring up a charge from infinity to a distance r from a second charge. For a point charge q1 at a distance r in a vacuum from another point charge q2, their potential energy is V equal q1 q2 over 4 5 epsilon naught r. Charge is expressed in coulombs, often as a multiple of the fundamental charge. Thus, the charge of an electron is minus E and that of proton is plus E. The charge of an ion is Ze with the Z charge of number. Positive for cations, negative for anions. The constant epsilon naught is the vacuum permittivity. It is conventional to set the potential energy equal to 0 at infinite separation of charges have the positive potential energy. The electron volt. The electron volt is defined as the kinetic energy acquired when an electron is accelerated from rest through a potential difference of 1 volt. The relation between electron volts and joules is 1 electron volt equal to 1.602 multiplied by 10 to the power minus 19 joule. So we discussed about work, energy and their some main terms. That's all gonna be from today's video. If you like this video, give a thumbs up. If you got any comments, leave in comment box, and thank you.